The second concern which comes to the mind of any new Linux user is software availability. The Linux operating system has huge software resources. The number of applications is counted in tens or hundreds of thousands, of which are usually available for free. And I'm not talking about the so-called free availability known from Windows, where freeware or shareware applications usually serve as some sort of advertising, or their functionality is limited, or we can only get the program in the form of a binary file. We're talking about the real and royalty-free availability of the full version of the applications, together with full source code, all the resources and other software components necessary to perform modification of this software, or sometimes even using it in a way that would be unexpected even for the creator of the software. Software resources are enormous. Of course, there is a question of quality with regard to this quantity. There are a lot of projects that are started to achieve some task, and unfortunately, they are never completed, or fail in the very early stages of development. For example, there's no runnable Flash editor for Linux. If an application has never gone beyond phase alpha, it's a real achievement to even run it. Huge amounts of software such as Office suites, graphics applications, games, multimedia applications work very well, sometimes even better than their Windows counterparts. Linux versions of some commercial software are available as well. The best example is MATLAB. It's obviously a paid app, available only in binary form. Please note here that even if the system is slow, it does not preclude the use of commercial applications. Unfortunately, the global market share of Linux end users is relatively low compared to Windows end users. And actually, a very small part of the well-known commercial Windows software is supplied in Linux versions. Later in the presentation, we'll see the counterparts for most of the applications used by ordinary users in their everyday work. I'll present their advantages and disadvantages, and what tools to use for particular tasks. These are not headline applications that would be well known to everyone. Sometimes the difficulty is not that some applications we need do not exist, but that we cannot find it, or simply we do not know about its existence. Unfortunately, we need to be aware of the differences in the approach to software development for Windows and for Linux. In the case of Linux software, it's created by software developers and for the software developers, and the fact that end users can benefit from the process is merely a side effect. Of course, not every program is like that. For example, Firefox is created for users, and it's more intuitive than, say, an application for drawing graphs, which is called NuPlot. That application offers a lot of the options and functionalities. But it's very counterintuitive when we first try to use it, since we're accustomed to certain behaviors in Windows. Another very important feature when it comes to the differences between Windows and Linux applications is the process of their development. Windows applications are usually shipped with all components necessary to run them. All DLL libraries, additional resources, helper software are available in the installer. Windows application is a monolith, an enclosed entity, which in fact does not require anything from the outside world to run. That of course has its upsides and downsides. On the upside, the components of the Windows application usually cooperate flawlessly. The downside is that we cannot use the spell checker tool from one application in another application, no matter how good it is. We're mostly stuck with what the application supplier has offered us. On the other hand, if a Windows application is delivered with some DLL libraries, which were originally intended to allow resources sharing, the problem of the differences between specific versions of libraries arises. What actually happens is that the application installs its own version, It's a waste of disk space and other system resources necessary to manage different versions of multiple libraries and ensure coherence, and it lowers the efficiency of the entire solution and completely defeats the purpose of all DLL libraries' existence. In the case of Linux, a software program is really a component that is designed to perform a specific operation, and usually performs it right. For example, supplementary operations are delegated to other programs, and other components specialized in performing given activities. Let's go back to the spell checking tool examples. In Linux, we have several spell checking tools. For example, aspell, isspell, etc. that can be used by virtually any application installed in our system. What we really have is one central dictionary, one central tool for checking spelling, which in turn is used by Office suites and by text editors, by email client applications, and by a variety of external programs. The advantage of this solution is that we have one central repository with, for example, some additional words. The effect produced in various applications is exactly the same. We're kind of prepared for how well the tool for checking spelling works. If our proofing tool proves to be weak, we can always replace it with another tool, which will automatically be used by other applications. This division of tasks in Linux also makes applications very specialized in what they do. Generally, if they're supposed to do something, they'll do it well. Thanks to such an approach, the developers of, for example, text editors can focus on specific elements of the editor, rather than re-implementing exactly the same thing their colleagues did when writing the spell-checking tools. Both approaches are equally good. They have their advantages and disadvantages. In Linux, the second is the most common solution. In the case of commercial solutions, though, the supplier may decide to use the monolith solution with its own dedicated components. For example, OpenOffice for Linux has two built-in dictionaries for spell checking. It can also use the tools on our system, but it doesn't have to. Once installed, the average distribution, just like Windows, has everything you need for daily work and multimedia, and more. In the case of Windows, Office packages are delivered in a very basic form. There's no Microsoft Word, and WordPad has very limited functionality. In the case of Linux, OpenOffice is the suite used most commonly, and it immediately provides full functionality. It's the same when it comes to multimedia. Everything just works. In fact, when it comes to software, a new user is faced with the problem of finding the right program, which performs the function he or she currently needs. Usually, the program is installed on your system right away. It's available for us immediately after installing Linux. We just need to know which program to use. An additional advantage of Linux is that very often, we can choose between applications performing similar functions. If we don't like a particular solution, we can easily move to another, which will probably be compatible with the one we abandoned, so we don't lose any file data. In the further parts of this course, I'll present various types of applications in detail, sometimes with a brief description to help you find the software right for you. Part of the software imported directly from Windows can also be run on Linux. Fortunately, Linux has a tool, which is called Wine. This is a special application that may not emulate Windows, but provides implementation of the interfaces between the operating system and applications. As a result, at least in most cases, we can run applications written for Windows in Linux. Later in this presentation, we'll take a look at that tool and familiarize ourselves with launching such applications. Unfortunately, it's not as simple as running native applications, but it's not that complicated as well. and only requires several mechanical operations that allow launching programs like Office applications, but also complex games.